536. 536. On this one, there we go. On this video, you're going to need protractor, definitely a highlighter, maybe even 2 or 3, and some stuff to write with. It may even be best to have some tracing paper, but I'm going to see if I need that in the moment, and then I'll get it if we need to. Okay, this lesson is going to focus on naming the sides of right triangles in terms of a reference angle and developing the relationship between the side length ratios and the reference angle. So by the time we're done with all of our lesson 1 content, you should be an expert at those 2 things and getting ready for the further I can statements along the way. Let's get into the getting started. Consider the parallel lines, that's good to know, parallel lines M and N. Locate a point on line N and label it P to create triangle JLP. So I see J. In fact, I'm going to put a dot here for J, which I noticed wasn't there in the beginning. And then somewhere out here, maybe not quite at the top, I'm going to put P. Okay, done. Then label the intersection of segment JP and line M as Q. And create triangle JKQ. Gone are the days JK would make students laugh thinking, he said JK, I know what that means. He's just kidding. But no, nope, that's gone. Okay, done. We want to verify that triangle JLP, I'm down here now, right? That triangle JLP and triangle JKQ are similar. So time for some color. And I think I like highlighting the bigger shape in yellow because yellow can be highlighted over much better than the other way around. So I'm going to highlight JLP yellow, JLP and back. And then I'm going to highlight JKQ, let's go green. Now again, you can use your own colors, but I think I like this color combination where yellow is the big one. So with this done. Now, next up, what we want to do is verify they're similar. And you know what the easiest way actually is? To use tracing paper. So I'll be back to grab some of that. Okay, remember, if we have triangles, then the 2 angles, we had that in one of our previous, topic 1. If 2 angles of one triangle match and are congruent to 2 angles of another, called the word corresponding, then we can say with confirmation that, yeah, the 2 triangles that they came from happen to also be similar. So if I go like this and I measure, automatically I know that angle J, that's a verification statement. We already know that this angle J is going to be congruent to this angle J. Even though they're like the same letter, both triangles are using them. And this is also another reminder, this is called the reflexive property. Okay, so then the second thing to do is to take this angle right here at angle K and just check if angle K and angle L happen to be the same angle. In fact, actually, I already know they're going to be the same angle. I remember that property, different color time. I remember that property from module 2, where we talked about when we have parallel lines cut by a transversal, then I should use the proper letters. Angle JKQ, that's this one, is going to be congruent to angle JLP. And the reason because of that is because corresponding angles in parallel lines are congruent. So we'll call them the corresponding angles. When we talk about whether or not 2 triangles are similar, I hope you remember back to when we did this in the previous topic, you have to show your evidence. And so the evidence is based upon 2 angles that are matching, so that one and these 2. And then last of all, we do get to say, yes, triangle JLP is not congruent, just similar, oh my gosh, pen, to triangle JKQ by angle similarity. You need all of that to really verify. You can, of course, you should be able to do transformations and verify that through the process of translation and then dilation, that the 2 shapes are similar. I also went with the route of saying, let me just check the angles, because if I can find 2 angles, then we're good. Okay, measure and analyze each pair of side length ratios. So I want to measure KQ, to JK. KQ, JK. Now I got to measure. So JK is, I'm going to use centimeters and millimeters, by the way. So here we have on the bottom, we have line up the 0 with J, and I'm sorry, there's a glare. Let's see if I can move the paper just a little bit better. That's better. Perfect. Okay. And then I notice 10 millimeters, 20 millimeters, 30 millimeters, 40 millimeters, 41. It looks like it's at 42 millimeters. So I'm going to write that off screen, but down at the bottom, I'm writing JK is 42 millimeters. Now, I need to know KQ. So KQ is this one. There's a reason why we're also measuring within the green shape. And as I measure this one, I notice it's lined up with 0, 10, 20, 30, maybe 31 millimeters. Of course, that's my measurement because I made that line in front of you right now. If you didn't make your line here be the right measurement, then when you measured KQ, this is totally on you. You need to do that part yourself. Let's carry out with the question though. And so the question says, let's compare that to LP and JL. So that's all the way from J out to L, and then from L up to P. Okay, measure. Millimeters still. This one should be the same for all of us, and I got 74 millimeters for JL. And then when I turn and measure up this way, this is not going to be the same for all of us. This is just relevant for me. So 10, 20, 30, 40, 50, 55 millimeters. Okay, maybe I could be a little more precise there. Sorry if that was a little askew for you in this video. Again, this number here is totally like yours, not mine. You found it. But this is why we want to do this. Hey Siri, what's 31 divided by 42?
It's approximately 0.738.
Okay, so that's the decimal that I got from taking 31 and dividing it by 42. Hey Siri, what's 55 divided by 74?
It's approximately 0.7432.
When you look at these and you say, they're not even close at all. Are you for real? They're absolutely close. They're like the same amount of money if you were to give somebody this on average. It'd be 74 cents, and this would be 74 cents. There's something about the ratio of sides where on this side to this one, it matches this one to the other. Listen, I showed you how to do number 3A. You need to go do 3B and 3C the exact same way, finishing out with some decimals here. That has been it for this episode. Thank you for watching. I will see you on page 537. Thanks for liking, commenting, and subscribing. See you in the next episode. Have a good one.